Welcome to examples of intervals of increasing and decreasing. So recall from the last video, we had a sort of 5-step process. We had a 5-step process. The first step was to find the critical values. The next step was to break into subintervals. Next was to pick test points. Then we were to find the sign of f prime at each test point. And then last up was to determine the intervals of increasing and decreasing, or increase and decrease. So we're going to run through a couple examples. Again, as I mentioned in the previous video, I'm not going to show or write out all of these steps this time as individual number lines. I'll show them kind of on one number line. So we need to first find the critical values. If we are going to find where g of x equals 3x to the fourth plus 8x cubed minus 6x squared minus 24x plus 12 is increasing and decreasing. So we need to find the critical values. So we are working with g of x is 3x to the fourth plus 8x cubed minus 6x squared minus 24x plus 12. So we would have that g prime of x is equal to 12x cubed plus 24x squared minus 12x minus 24. And then we want to figure out where this is equal to 0 or undefined. Again, in this case, this is a polynomial, so it's never undefined. Okay. So we can go ahead and just start solving where it's equal to 0. So we can factor out a 12 from this whole thing. And we're left with x cubed plus 2x squared minus x minus 2 equals 0. It's probably been quite a while since you've seen factor by grouping, so we're going to do a little review of factor by grouping. We're going to go ahead and group x cubed plus 2x squared, and then we'll group negative x minus 2. That first group, we can go ahead and factor out an x squared from those first two terms. So we'd have x squared times x plus 2. That second group, we can pull out a negative 1. So we pull out a negative, we're left with x plus 2. This is all equal to 0. Then we have common factors of x plus 2. So we can go ahead and pull out an x plus 2. And we're left inside with x squared minus 1. So again, we're just taking this x plus 2 and pulling them both out front. This is all equal to 0. And then x squared minus 1 itself also factors. So we have 12 times x plus 2 times x plus 1 times x minus 1, this whole thing set equal to 0. And so this could be either x plus 2 equals 0, x plus 1 equals 0, or x minus 1 equals 0. And therefore we get that x is -2, -1, or 1. So these are our critical values, our points of interest. So now we're going to go ahead and run steps 2 through 5, essentially. So we're going to draw the number line. So if we draw our number line, here's our x's down below. We have 3 points of interest, -2, -1, and 1. You do not need to worry about the spacing actually matching the spacing on a number line. The main point here is that they're in order. Then we have f prime of x up above. So again, all of these places, the derivative was equal to 0. Now, for the test points, I'm going to, again, remind myself that f prime of x was equal to 12 times x plus 2 times x plus 1 times x minus 1. And I'm just going to do not even picking a specific value. If we pick something in between, or sorry, if we pick something less than -2, that 12 is going to be positive no matter what, and the rest will change. So we'll have a positive times something less than -2, say -3. -3 plus 2 will be negative. And then -3 plus 1 will be negative. And -3 minus 1 will still be negative. Again, you could use a specific point or just know that the value is less than -2. So I used x equals, I guess technically we used x equals -3. Right. And so positive times negative times negative times negative. We have an odd number of negatives, so we get a negative result. Then we might pick, say, -1.5. That's between -1 and -2. 12 is still positive. Now, -1.5 plus 2 would be positive as well. That sign has now switched. -1.5 plus 1 is still negative, and -1.5 minus 1 is still negative. And so we wind up this time getting a positive result. Something between -1 and 1, I might as well pick 0. 12 is still positive. 0 plus 2 is positive. 0 plus 1 is positive. 0 minus 1 is still negative. That one has not yet switched. And we wind up getting negative overall. And then say at 2, we are still positive at 12. 2 plus 2 is still positive. 2 plus 1 is still positive. And now that last factor has also switched. So this time around, we again are positive. So we just figured out that f prime of x was started off negative, switched to positive, switched back to negative, and switched back to positive. Notice at each critical value, the factor that corresponds to that critical value essentially switched signs. The only place where this will not happen is if that factor is a repeated root. So for example, if we had x plus 2 squared, that factor again would always be positive. So it's not going to switch signs at its critical value. But as a general rule, essentially critical values will typically have a switch signs unless it's got a square or cube or unless it's got an even power on that factor. But But just to be safe, I recommend writing them out and seeing what happens. So at this point, now we're going to do our increasing and decreasing. So f of x, we start off with a negative derivative, so we're going down. Then it flattens out. Then we switch to positive, it's going back up. And then it flattens out, switches to negative, goes back down. Flattens out, switches to positive, goes back up. So we immediately have where this is increasing and decreasing. I'm just going to give myself a little more space so that we can write out this full answer. If we put our intervals, oops, we write our intervals. We have that it's increasing on from -2 to -1 was our first up arrow. And then again, from 1 on forever to infinity. And it's decreasing on from -infinity to -2. And then from -1 to 1. And then also just things, if you want to follow along in terms of the ordered steps, what I did in this color was step 2. What I did in purple was steps 3 and 4. And then what I did in blue was step 5. So dark blue was step 2, the purple was steps 3 and 4, and light blue was step 5, if you wanted to kind of go along. But this is what I would do personally for this sort of problem. Again, if you want to evaluate specifically to find f prime at each of your test points, you absolutely can, and you could just write f prime of -3 equals and whatever number it would be as well. All right, let's go ahead and do one more example. So our job now is to find where h of x equals x squared minus 1 all over x plus 3 is increasing and decreasing. So again, the first thing we need to do is find the critical values. So we have that h of x is x squared minus 1 over x plus 3. So h prime of x, we're going to have to do a little quotient rule. We'll do the derivative of x squared minus 1 times x plus 3. Then we will subtract off x squared minus 1 times the derivative of x plus 3. And then divide by x plus 3 squared. So this becomes 2x times x plus 3 minus x squared minus 1 times 1 all over x plus 3 squared. I do highly recommend simplifying that numerator because to figure out to find where the derivative is equal to 0, you're going to want to have that simplified anyways. So this becomes 2x squared plus 6x minus x squared plus 1 all over x plus 3. Oh, I lost my squared. All over x plus 3 squared. And then this simplifies to x squared plus 6x plus 1 all over x plus 3 squared. So if we set this equal to 0 or undefined, this is a rational function, so we will have a couple places or somewhere where it is undefined, at least in this situation. So it's undefined when x plus 3 squared equals 0. Or in other words, when x equals -3. And then if we do where it's equal to 0, this one we have x squared plus 6x plus 1 equals 0. We could use the either complete the square or do the quadratic formula or quadratic equation. So we have a would be 1, b is 6, c is 1. We have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And if you've forgotten that quadratic equation or quadratic formula, so we have -6 plus or minus the square root of 6 squared minus 4 times 1 times 1 all over 2 times 1. Or -6 plus or minus the square root of 36 minus 4 would be 32. All divided by 2. We can do a little simplification if we wanted. This is -6 plus or minus the square root of 32 has a 16 times 2 inside. So it actually simplifies to 4 times the square root of 2 over 2. Or -3 plus or minus 2 root 2. So we have our critical points or critical values. We had x equals -3 minus 2 root 2. Then x equals -3 was where it was undefined. Sorry about that. I got two problems confused for a moment. I was thinking I'd made a mistake. And so we have -3 was where it was undefined. And then we have -3 plus 2 root 2 as our last option. So from here, we're going to create our number line. So main thing is just that the numbers need to be in order. So -3 is going to be in the middle. -3 minus 2 root 2 should be to the left. And -3 plus 2 root 2 should be to the right. This was x along the bottom. Then we'll do f prime of x. And then at the end, we'll do f of x. So again, at -3, f prime was undefined. And then at the two other values was where f prime was equal to 0. So now we're going to go ahead and pick test points. So for test points, I might pick -4 and -2 just to be safe. So 2 times square root of 2 should be somewhere close to 3. So we could go farther away, but just to be safe to make sure that we're not going too far away. And then on the outsides, I might want to actually check the value of -3 minus 2 root 2 and -3 plus 2 root 2. So if I do that check, that's going to be about -5.8 for this one here. So again, this first point is about -5.8 approximately. And then the other one is approximately -0.2. So I would go out to say -6 on the left and 0 on the right. So we now have 4 test points, not 3 like the example before. Or the example before was also, oh no, the example before we did have 4 test points. Okay, I'm forgetting what problems I've done one. It's just that they're not all zeros for the derivative. Again, our derivative itself, so we had the f prime, actually, is it f or are we h? Sorry for all the spelling, h. So this is h prime. I think the other one was actually g, but that's okay as well. So h prime of x was x squared plus 6x plus 1 all over x plus 3 squared. So note that this denominator here, this part's always positive, or always aside from at -3. So this part's going to be positive. So we're really just concerned with the numerator. We could factor the numerator, or we could just evaluate. So since our roots are not the most pleasant numbers this time around, factoring is going to not be the most pretty. I would just evaluate. So if we plug in the numerator, so if we do h prime of -6, we would have -6 squared plus 6 times -6 plus 1, and then it'll all be over a positive number. So I'm not going to worry about the denominator. So we'll have a positive 36 plus a minus 36 plus 1. So we'll get a positive over a positive, and we have a positive result. So we know that we get a positive for that first one. Then at h prime of -4, we'll have -4 squared plus 6 times -4 plus 1 all over a positive value. This top we'd have a positive 60 minus 24 plus 1 would be a negative divided by a positive, which will be negative. So on our number line, we have a negative now. At h prime of -2, we will have 0 squared plus 6 times 0 plus 1, all divided by a positive. And so we wind up with a positive over a positive. And that's a positive answer. And something seems off there since we have an x plus 3 squared in the denominator. We shouldn't be switching signs. Oh, sorry. I switched from -2 to 0 somehow. sorry about that. I was getting ahead of myself. Negative 2 squared plus 6 times negative 2 plus 1. That becomes negative over positive, and that gives us a negative result. And so on our number line, we'll have another negative. So again, as I mentioned in the previous problem, the only place where we don't switch signs is if we have a repeated root or a repeated place of undefined. So that x plus 3 squared, that's where the negative 3 came into play. But since it's squared, it's not going to switch signs as we pass through it. Our last test point was at 0. So h prime of 0. Now the one that I tried to do a moment ago, 0 squared plus 6 times 0 plus 1. And then we're dividing by that positive value. And we have a positive over a positive. And so we get a positive. So our number line now looks like this. And so we can go ahead and fill it in. We start off increasing, switch, go flat, switch to decreasing, have a break, stay decreasing, go flat, and then switch to increasing. So we're increasing on the two outsides. So we're increasing from negative infinity to negative 3 minus 2 root 2. And then from negative 3 plus 2 root 2, oops, on to positive infinity. And then we're decreasing from negative 3 minus 2 root 2 to negative 3, and then again from negative 3 to negative 3 plus 2 root 2. It turns out the actual function in this case has an asymptote at negative 3, so there will legitimately be a break in the function. But this is just figuring out increasing and decreasing. Again, I did the same color coding as the last time, so the steps are kind of laid out. But this is a way for you to go about figuring out where the function is increasing and decreasing precisely without using a graphing calculator, without graphing the function.